All right, guys, I'm back. Promises, promises. Told you I'd be back. So today we're going to talk about electrons again. This video will be for Wednesday and Thursday, November 11th and 12th, okay? And so I'm going to go through and review a little bit of stuff that we talked about last time because it was kind of confusing, and then we'll push further, okay? And I'm going to do another timer. I'm going to start it for 30 minutes, all right? So how are electrons organized in an atom? They are in shells in the atom, right? How can we use the periodic table to predict electronic structure? We can look at the location of elements on the periodic table, and it will tell us everything we need to know about electronic structure. How can we express the electronic structure of an atom, or how can we explain or describe how electrons are organized around an atom? We're going to use something called electron configuration. We're going to talk about that today. All right, so electrons, the last shell is called the valence shell. So if you look at this one, it's that last shell that's furthest out from the nucleus. So as you fill shells and work your way out, the last one is called a valence shell. And it's important because it's involved in bonding and chemical reactions. All of the other shells are not involved. Okay? The group number that you are in tells you how many valence electrons you have. So if you look at the periodic table, group 1 is 1 valence electron. Group 2 is 2. Group 3, 3. Actually, that's group 13. I call it group 3, but it's got 3 valence electrons. 4, 5, 6, 7, and 8. So if you look at your periodic table, the row that you're in, or I'm sorry, the column that you're in, tells you how many valence electrons you have. Okay, so if you're an element and you're in here, you have 1 valence electron. So that means if you draw your atom, there's your outermost shell has 1 electron in it. That's what it means. Okay, if you're in group 2, that means that your outermost shell has 2 valence electrons in it. So there's 2 of them. There's one there and there's one there. Okay, so both those electrons are in that outermost shell. If you're in group 3, then you have 3 valence electrons. Kind of like boron. Boron's got 3 valence electrons. 1, 2, 3. If you're in group 4, you got 4. Kind of like carbon. If you're in group 5, you got 5, like nitrogen. Okay, and I'm drawing Lewis dot diagrams for these elements. Group 6, you're going to have 6 valence electrons. 1, 2, 3, 4, 5, 6. Group 7, you're going to have 7. So fluorine has 7 valence electrons. 3 pairs and 1 single. And then group 8 will have 8 electrons. So like neon will have 8 electrons in its outer shell. It'll have 4 pairs of electrons like that. Okay, so the column that you're in, this is a column here, right? This purple one. These columns will tell you how many valence electrons you have. All right, so we got to understand that. Okay, and then remember that the groups in the middle do not follow the rules. Okay. Lewis dot diagrams show you the valence electrons. So let me draw these again. Group 1, like hydrogen, will have 1 valence electron. Group 2 will have 2 valence electrons, like magnesium. Group 3 will have 3 valence electrons, like boron. Group 4 will have 4, like carbon. Group 5 is going to be like nitrogen with 5. Group 6 will be oxygen with 6. Notice that I spread them out and then I pair them up. Group 7 will be like fluorine. 3 pairs and 1 single. And then group 8 will be like neon, which will have 8 electrons. Now, it is important to note that helium is also in group 8, and he only has 2 valence electrons, but it's because helium is part of the first shell, and remember that first shell can only hold 2 electrons. So helium will have 2, and he's got a full outer shell. Neon and every other element, the second outer shell can hold up to 8. Okay, so helium, this is going to be in group 8. He can hold 2, but he's kind of weird. And then the rest of the groups in group 8, the rest of the elements in group 8 can hold 8 valence electrons. Okay? We did these examples here. I'll do them again, I guess. Hydrogen, lithium, carbon, and oxygen. Okay? How is the periodic table arranged? Each of the rows or the periods indicates the electron shell number or the energy level. There are 7 principal energy levels. one for each row on the periodic table. So as you go down the periodic table from top to bottom, each row from left to right is a principal energy level. As you move out from the nucleus, each shell becomes higher in energy or more unstable. And so if you look at our periodic table, we just said that as you go across the periodic table, you have 1 and then 2 and then 3 valence electrons, 4, 5, 6, 7, and 8. So you're filling that outer shell. All right, so this is going to be what hydrogen is going to look like. It's going to have 1 electron in its outer shell. There's not an element there. Helium will have 2 in its outer shell, so it'll have 2 hanging out there. Boron will have 3. Carbon will have 4. Nitrogen will have 5. Oxygen will have 6. Fluorine will have 7. And neon will have 8. Okay. All right, now let's talk about the energy level. As you go down the periodic table, the first level is level 1, and it has hydrogen and helium. Hydrogen can have 1 electron in its outer shell, so we call it the 1s. And then helium can hold 2, so we're going to call it 1s2. Okay? And I'll talk about these symbols in a little bit. So 1s1, 1s2. And then when you get to level 2, it's going to be 2s1 for lithium. And then this is actually going to be 2p1. But notice that it's level 2. So this is level 1, these 2 guys. This is level 2, these guys and these guys. These are in the 2s, these are in the 2p. These are in the 3s and the 3p. All right, and then 4s, 4p, and so on. Okay, and there's a total of 7 energy levels. 7s down here, 7p down here, and then I think the largest D, these are D block elements right here. The largest, so that's 3, 4, 5, 6. So that'd be 6D will be the largest D. And then remember the bottom 2 at the very bottom, that's the 4F and the 5F. Those are F block elements. Okay. Okay. Electrons are arranged into shells or principal energy levels around an atom. The space available around an atom where electrons are held are called orbitals. Remember I talked about how they're kind of like a twin bed, and they can hold 2 electrons. There are 4 shapes or sublevels: the S, the P, the D, the F. The S is like a sphere. It is the simplest sublevel. Then there's the P and the D and the F, and they get progressively more complicated. And this is what they look like. Let's go over this again. If you're looking at the first shell on the periodic table, you're looking at hydrogen and helium. Okay, so there's hydrogen and helium. The first shell is just going to be the 1s. And so that's the only shape that's available. Okay, and so hydrogen has 1 electron in its outer shell. And so we can say, okay, it's 1s1. Helium will have 2 electrons in that first shell. And so we say 1s2. It's still 1 right here because it's still in the first row on the periodic table, right? It's still in the first energy level. All right, and then the second level, you will have the S, so that'll be the 2s, and you'll have the 2p. So you'll have this one right here and this one. Okay. When you get to the third level, you will have the 3s, the 3p, and the 3d. So you'll have this guy too. So that's on the 4th level on the periodic table. 4th row as you work your way down. So that's 1, 2, 3, 4. So if you're looking at the first group metals, this will be hydrogen, this will be lithium, this will be sodium, this will be potassium. Okay, and then if you get to the 4th level, you now have the 4s, the 4p, the 4d, and the 4f. So now you're adding in those f orbitals. So spdf. Okay, S is the sphere, P is the peanut, and we're not really worried about too much about how they look. But you need to understand that the first level has the S. Second level has the S and the P. Third level has S, P, and D. 4th level, you have S, P, D, and F. And so each time you go down 1 level, you add a new shape. So first level, you have just the S. Second level, you have the S and the P. Third level, you have the SP and the D. Fourth level, you got all of them. Okay? Now let's talk about how many electrons fit in each shell. So this can hold 2 electrons. Each of these can hold 1. And so how many electrons can fit in an S level? Just 2. That's it. Then it's full, right? This is our first shell. So only 2 electrons can fit in there. All right, how about the P? That's a total of 6 if you count them. So that's 6. The D, 1, 2, 3, 4. I'm trying to think. 1, 2, 3, 4, 5 is 5 orbitals, and so that's 2 each. And so that's 10. So this is 2, this is 6, this is 10, and then the F is 14. So let's look at that. 2, 6, 10, and 14. And so we're talking about how many electrons that they can fit in, okay? And we can think about it like this. Let me erase the slide. The S level is like the beds. You can have 2 kids, 2 small children sleeping in a bed. Okay, and that looks terrible. So there's our 2 children sleeping in a bed. You can think of P's as 3 rooms. So you've got 3 rooms, each with their own bed. So here's a bed here, here's a bed here, here's a bed here. So this is a room with 3 beds, and so you can sleep 6 children. Is that making sense? So 3 different beds all in a room. Okay. So that's 2 beds in this one. So you can have 2 kids sleeping in this one. And then you can have, I guess, 3 rooms. Okay. And then let's say that this is the floor. So if you go down to here, you go to the second floor, and you can have more space for lots of rooms. So maybe each of these is like a room, right? And then this is like the next level. Okay. So let's talk about this, like how we're going to feel electrons. So let's talk about our school. So let's say that we wanted to have a summer camp. Okay. And we wanted to have kids come and stay at the school. Let's say that we needed to have them spend the night. All right. And this was like a summer camp. Let's say if we're going to get the kids to come, basically what we're going to do is we're going to fill this lower level first. So that's called the first energy level. And then we're going to put them in this bed first. This is called the 1S. Okay. And then in terms of electrons, this is full. Let's say that the first floor is mostly like offices and stuff. And so there's only 1 classroom to put students. And so only 2 students will fit on that first level. And then we got to go to the second level. Okay, the second level will have the S and the P. And so we'll have the 2S, which will fit 2 students. Okay, and then we'll have the 2P, which will have 3 beds and 6 students. And so that's a total of 8. So 2 on that first level. And like I said, the first level is mostly offices and stuff. And so we're only going to have 2 students that can stay on that first level. Then it's full. And then we're going to start taking students and move them to the second level. And that second level can have, some can stay in this classroom, the 2S. Some can stay in the 2P. All right, and that's where they're going to live. So some of them will go here. Some of them will go here. Okay. So 2 in that one, and then 6 in that one, so a total of 8. Now let's go to the third level. We have the 3S, which is this one. It can hold 2. So that's going to be 2 electrons that can stay there. We're going to have the 3P. It can hold 6 just like before. But now we're going to have the 3D. So as you go up each floor, you have more rooms. You have more space for students. Okay? I know this is a weird school, but that's how the electrons kind of work. As you go up more levels, you have more place to put electrons. And so you also have the 3D, which can hold 10. So how many total electrons in that third level? 2 for the 3S, 6 for the 3P, and 10 for the 3D. So that makes 18 total. All right, and then the fourth shell, you will have the 4S, the 4P, the 4D, and the 4F, and that'll fit 32 students. And so now we're at a room. Okay. So 2 students can go on the first level with the offices and maybe the teachers and principal. The second level can hold 8. Third level can hold 18, and fourth level can hold 32. Okay, so you can almost think of these levels like stories of a building. And I hope this helps relate the information. Okay, so we got S for sphere, P, D, and F. Here's where they are on the periodic table. And I showed you guys this. So this is the S block. That means that their valence electrons are in an S shell. That means if you look at that atom and you look at the outermost shell, so let's look at sodium. Sodium has 11 protons. There's its first shell, second shell, third shell, and that third shell has 1 electron in it. Well, guess what that 1 electron is in? It's in an S. So that's going to be called the 3s. Okay? So all of these guys have their valence electrons in an S level. That means that the shape of the electron cloud on that last outer shell is a sphere. That's all that means. It's an S orbital. It's a sphere. Okay? Anything over here in this group, and actually these guys too, all of those would count as well. This is the 2p, 3p, 4p, 5p, 6p, and down here is the 7p. And so all of these guys, if you look at their outermost shell, they have their electrons in the p orbital. Okay? They have some electrons in the s and some in the p. Okay? Now if you look at your d block elements, their valence electrons will be in a d orbital, which is getting really big. It can hold 10 electrons. Okay, and the first one is called the 3d. That's this one, 3d. And then the 4d, 5d, and 6d. Okay, so that's 3d through 6d, and each of those can hold 10 electrons. And so this element, like here, iron, his outermost shells will be in a D shape, okay, which is for Daisy. All right, and then these guys down here will be F. So this is the 4F, and that's the 5F. And then this one is the last shell. That's as big as it gets. And they can hold 14 electrons. Okay. All right, now let's look at this again and relate it to how many electrons you can hold. Let's look at the S. So how many electrons are in this first shell? Look at the first column on the periodic table. I'm sorry, the first row on the periodic table, which would be this one right here. This one right here, right? Notice that there's only 2 elements. There's nothing here. You got 1 and you got 2. And so if you count on the periodic table how many elements are in that row, you can see that the first shell can hold 2. The 1s, and this is also 1s, but we're going to say it's 1s2. This is 1s1, okay? And I'll show you what I mean by that in a little bit. So that's the 1s. Now let's go to the second level. This is the 2s right here. So we can say 2s2. That means that the 2 of those electrons will be in a 2s shape. And then these guys will be in the 2p. Count them. 1, 2, 3, 4, 5, 6. We got 6 right here. And let me erase this. We got 2 right here, right? 1, 2. So it's 2 electrons total. Let's count these. 3, 4, 5, 6, 7, 8. 8 electrons in that second shell. 2 electrons in the first. Now let's count the third shell. Third shell has these guys. That's 2. It has these guys, which is added an additional 6. And then it also has these guys. Even though it doesn't look like it does, it has these guys. You got to remember, guys, that first D level, scandium through zinc, this is called the 3D, and it can hold 10 electrons. So 10 plus 6 plus 2, so that's 18. So the first level can hold 2, second level can hold 8, third level can hold 18. Then let's look at the fourth level. Fourth level will be these 2 guys, that's 2. It'll be these guys, which will be 10. It'll be these guys, which will be 6. And oh, now we've got the F, which is 14. Notice that there's 14 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Notice that the D's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why they can hold 10, 1 for each element. Okay? And I hope this is kind of making some sense. I know this is confusing. Here's it labeled again. So let me add some stuff here. So this is the 1s. So that's 1s1, that's 1s2, 2s. All right, so this is the first level, second level, third level, kind of like floors on a building. Goes all the way down to 7. The first P is the 2p, and it's over here. That's boron to neon. Then the 3D starts here at scandium and goes to zinc. Iron is in here, copper's in here. Okay. And then the F starts right here. That's the 4F and the 5F. Okay. And so you can see where everything is. Okay. Let's see what we got here. So there's our 7 principal energy levels, 1 through 7 there, and then 6 and 7 there. So the row number is equal to number of shells. The group number, remember, is the number of valence electrons. So first group, second group, third group, fourth. So 1, 2, 3, 4, 5, 6, 7, 8. And then at 8, you fill that last shell. There's the S block. There's the P block over here. There's the D block and the F block. No, there's no cell block C. Sorry. There's S block, P block, D block, and F block. Okay. Notice that that's also S. Helium is also S because that's hydrogen and helium are the 1s. Okay, let's look at the electron configuration because I keep showing you guys this, and I want you guys to understand what we are talking about. So what does the 1 stand for? The very first number in the first part of the electron configuration. It is the row number. It is the shell number. The possibilities are 1 through 7 because there's 7 rows on the periodic table. So if you're looking at the periodic table, first, that's 1, that's 2, that's 3, that's 4, all the way down to 7. And then these 2 are 6 and 7, the last 2. Okay? So that's what that means. That's the shell number, the principal energy level. All right? And then this will be the group number. This will be the number of valence electrons. So when we write 1s1, we mean that it's the first principal energy level. Let's see if I can write this. First level. When we write S, it means that the shape is an S. Well, that's the sublevel. Shape equals S, that's the sublevel. And then when we write 1, it's an exponent. Everybody see that? It's an exponent. So it's 1s1. So it's a small number. So that small number tells me how many electrons are in that shell. So this shell is called the 1s, and it has 1 electron in it. So that's what 1s1 means. 1s meaning first energy level, S for S shape. It's on the S block, and it has 1 electron in it. Now let's add an electron to this. It'll be like that. First level, S, and 2. And then after that, you're full. The 1s can only hold 2 electrons. 1 and 2. And remember, it's full after that. S can hold 2, P can hold 6, D can hold 10, and F can hold 14. All right, and so that's the max number of electrons they can hold. Okay, and so we're going to add electrons to that shell. We're going to start with the 1s, then the 2s, then the 2p, the 3s, the 3p, the 4s, the 3d, and we're going to continue filling from the inside of the atom out, and we're going to fill each shell until we run out of electrons. Okay. Okay, let's practice. So we should try to ask these questions every time we write an electron configuration. So find the element on the periodic table. It's atomic number 3. So it's a period number 2. So how many shells does it have? It's going to have 2 because it's on the second row. What's the group number? It's 1. So how many valence electrons? It's going to have 1. What sublevels does it have? It's going to have the S. And then the configuration will be 1s2, 2s1. All right. Let's go back to the periodic table and look at how we got this. So keep this in mind as I go back. So I can only show one screen at a time. 1s2, 2s1. How did we get that? Let's go back. Let me find one that I like a little bit better. Okay, I like this one better. All right, so let's look at this one. So let's look at how we start. So when you start doing electron configuration, you're going to start with hydrogen. It's the first element. Notice that he is on the 1. And remember that this is the S block. All of that is the S block. So the first thing I'm going to write is 1s. And I'm going to say, okay, the first electron will be hydrogen. The second one will be helium. So we can cross those out. I'm going to write 1s2. And then that first level's done. 1 is the energy level. It's the row on the periodic table. It's 1 because we're up here. It's S because this is the S block. So anything over here will be S. Remember that this is also S block as well, just helium. Remember that these guys are the P. Okay. All right, now let's look at the next one. So we follow atomic number. We did hydrogen, that's the 1s1. We did helium, 1s2, and so we write 1s2. That means that the shell is called the 1s, and it has 2 electrons in it. Okay, and then that's full. Now we go to this guy. We're going to go to lithium. He's on the 2. He's on the S block, so we're going to write 2s, and then we're going to say, okay, we're going to put 1 electron in that shell, and then we're at our element, right? We got 3 electrons. If you add up the exponents here, the 2 plus the 1, what do you get? 3. And we said that we were lithium, right? So lithium is atomic number 3. And so 2 of those electrons are in the 1s. So we write 1s2. And then that last electron has to go in the next shell because the first shell is now full. And so it's going to be called the 2s1. So the first shell is the 1s. The second shell is the 2s. Each of them can hold 2. Okay? And so I want you guys to be able to look at the periodic table and see how we're doing this. Okay? I hope this is making sense. It's kind of difficult, and I understand that. Okay, let's get back to example. So we did lithium, and so that's our configuration for lithium. 1s2, 2s1. All right, let's look at boron. Boron is atomic number 5. It's row 2. It's got 2 shells. It's group 3, has 3 valence electrons. It has the P is the sublevel of the valence shell because it's in the P block, and that's the electron configuration. So let's look and see how we get this. 1s2, 2s2, 2p1. Let's go back to the periodic table that I like. I like this one just because it's clean. And so let's start at hydrogen again. It's in the 1. Remember that this is the S block. This is the P block. All of that is the P block. This is the D block, which we won't get into right now. So let's look at boron. We have to start at hydrogen. We have to start here and go 1 element at a time and add it up. So let's write it. So this is 1s1. We put 1 for the first element. And then 1s2. Let's cross that off. So it's 1s2. And then we're going to write, oops. We're going to write 1s2. And actually what we'll do, instead of writing it like this, 1s1, 1s2, we're just going to write 1s2. Okay, so that's what I'm going to write for hydrogen and helium, 1s2. And that means that this guy's gone, and then this guy's gone. It's 1 because we're on the first level. It's S because these are both S block elements. Now we're at the 2. We're going to do lithium and beryllium. So that's going to be 2s2. Now they're gone. We keep doing this until we get to our element. Our next element is boron. This is the second level, right? That's a 2 there. And we're on the P block. So this is 2p, and it's the first element, so 1. Now add up our elements, add up our electrons here. 2 plus 2 plus 1 is 5. Isn't that the atomic number of boron? And so that's our electron configuration for boron. You start with hydrogen, you fill the 1s, you say 1s2, and then you go down to these guys. You do 2s2, and then you go over here to boron. And so let's look at this. Let's start writing the electron configuration for a lot of these elements from the periodic table. So hydrogen is right here. It's in the S block, right? Remember, this is the S block. This is the P block. This is the D. And then the guys down here, all of these elements down here, there's 2 rows down here. That's the F. Okay? So if we're going to start with hydrogen, we're going to say it's 1s1. If we're going to do helium, 1s2. So that's hydrogen and helium. If we do lithium, right here, we're going to have to say 1s2 is full and then 2s1. Okay? You can't just put the 2s1. You have to include the inner shell because lithium has both shells and you're working your way out. And so if you're building lithium, there's your nucleus. The first shell is the 1s, and it's got 2 electrons in it. So we put 2 electrons in it. And then you go to your next shell, which is called the 2s, and it has 1 electron in it. And so that's lithium. All right, beryllium has got one extra electron in that 2s. So we're going to write 1s2 to say that that first shell is full, and then 2s2. That second shell will be full. All right, now let's go to boron. Boron will be 1s2, 2s2, and then it's going to be 2p1. What is carbon going to be? Carbon will be 1s2, 2s2, 2p2. And the reason it's 2 is because boron is the first p, and then carbon is the second. What about nitrogen? Nitrogen's right here. It's going to be 1s2, 2s2, 2p3, because that's the third element. 1, 2, 3. All right, oxygen will be 2p4, fluorine will be 2p5, neon will be 2p6. All right, let's practice that. There's our blocks there, S, P, D, and F. All right, we did lithium, we did boron. All right, this is the order. Let me go back. Previous. There we go. So here is the order all the way through the periodic table. So as you're writing electron configuration, this is the order. 1s2, 2s2, 2p. Well, let's say it. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, and so on. So that's the order. If you start from the beginning and go all the way to the end. So if you wanted to find the electron configuration for the very last element on the periodic table, this is what it would look like. Okay, so they get kind of long. And there is a shortcut, and we'll learn a shortcut later. All right, so let's write the full electron configuration. Sometimes we call it the ground state electron configuration. So full ground state electron configuration for these elements. So let's write them. So if we're looking at our periodic table for hydrogen, it's in the 1s, and there's only one electron. Helium will be 1s2. All right, I'm going to write the atomic numbers here. Atomic number 1, atomic number 2, number 3, number 4, number 5, and 6. Okay. Let's draw a periodic table here. So there's this guy. So this is pretty good. So this is hydrogen. This is helium. This is lithium, beryllium. Here's boron and carbon. All right, so I'm going to change colors here. And so this is the S block. This is the P block. This is the D block. And then remember the 2 rows down here is the F block. Okay? And so as we start with hydrogen, it's in the first level. And so we're going to write 1. And remember, this is the S block. This guy right here. That's the S block. And so we're going to write 1s, and only 1 electron goes in there because his atomic number is 1. He only has 1 electron. And so that's his configuration. Helium will have 1 extra electron, so 2. And then that 1s is full. And so for these other elements, they are all going to include 1s2 because that first shell is called the 1s, and it always holds 2 electrons. And so as you go to bigger and bigger atoms, you're going to have more and more electrons beyond that. And so lithium will have 1s2, and then lithium is right here on the 2s. And you got 1 electron left, right? That's 3 electrons because it's atomic number 3. Remember, you can get 3 by adding up the superscripts, the exponents. 2 plus 1 is 3. Beryllium is 1s2, 2s2. Boron is 1s2, 2s2. And then it's over here at the 3p, and it's the first element. So that's 3p1. And then this will be 1s2, 2s2, 3p2. And then we'll be done. Okay? Those are configurations. Fun. I'm not going to do these again. I just did those. Oh, let's do sodium. Sodium is element number 11. And so the first shell is the 1s, and I can put 2 in there. So let's start with our nucleus. The first shell is called the 2s, or I'm sorry, the 1s. And I can put 2 electrons in there. So there's 1 electron zipping around. There's 2 electrons. Now that second shell is called the 2s, and I can put 2 electrons in there. 2s2. Remember, the s's can only hold 2. Then that third shell is called the 3p, and it can hold 6. So I'm going to write 3p6. And then I got to go 1 more shell, because right now I got, how many electrons do I have total? I got 2, 3, 4, and that makes 10. So I got 10 electrons. I got one left because I got 11 electrons. So I got one more shell to do, and that last shell is going to be called the 3s. 3s, not 4. So that'll be the 3s. So let's write our configuration. We got 1s2, 2s2, and I'm circling them. That's actually 2p6, not 3p, 2p6. 2p6. And then we got 3s2. Actually, it's 3s1. Because look how many electrons we got now. Let's add these up. 2 plus 2 plus 6 plus 1 is 11. So now I got 11 electrons. So I got 2 electrons in the first shell. And then I got 2 electrons in the second shell. Looks like that. I got 6 electrons in the 2p. And then I got the last 1 electron in the 3s. All right, so let's go back and look at sodium on the periodic table and see if we understand that. Come here, Mr. Sodium. I want to have a chat with you. All right, Mr. Sodium. Here's sodium. Let's look at this. So the first one was 1. And remember, this is the S block. All of this here is the S. This is the P. Okay, we don't have any D blocks, so we're not worried about that. So if we start at hydrogen, we got to say, okay, hydrogen is 1s1, 1s2. That counts those two, 1s2. And then we got to do these two. It's 2. So I'm going to write 2s. It's S because it's in the S block, and it's 2 because there's 2 elements. And then we got to do the 2p. Right? This is the second level still, right? I don't know if y'all can see that. I got my stuff on top of it. There we go. So that's the 2. And remember, this is the P block, so that's 2p, 1, 2, 3, 4, 5, 6. And those are gone, 2p6. And then voila, we're at the sodium, and it's in the 3s. It's 3 because it's on the third row, and it's S because it's over here. All of these guys are the S block. So 3s1, and then there's our 11 electrons. Beautiful. All right, we are almost done here. Okay. What are the rules for filling electron shells? The lowest energy shells must be filled first. The first shape, the 1s, can only hold 2 electrons. Only 2 electrons can occupy a single orbital. So these are our rules for filling electron shells. How many electrons can go in each sublevel? The S can hold 2, the P can hold 6, the D can hold 10, and the F can hold 14. Okay. I think there's supposed to be something down here. Number of orbitals. You can divide this by 2 to get the number of orbitals. So let me go ahead and fill this in. So S will only have 1 orbital, and it's just a sphere. So it's just a sphere. The P will have 3 orbitals. Remember, it's like there's that one, and then there's that one, and then there's that one. And so that's the 2p would be the first example of that. And it can hold 1 electron in each of those orbitals. So that's 3 orbitals total. There's this one, and this one. And actually the way this works is this is in like 3 dimensions, x, y, and z. Kind of like if you make a graph, you got x and you got y, right? And then if this one came out at you, that'd be the z. So it's 3 dimensions, x, that would be y. My writing is messed up. Let me write this. X, Y, and Z. Okay. The D will have 5 orbitals, and the F will have 7 orbitals. So you can take this number and divide by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. 10 divided by 2 is 5. And 14 divided by 2 is 14. So take the max number of electrons in each shell divided by 2 to get the number of orbitals. An orbital is 2 electrons. 2 electrons, okay? All right, what else we got? 2 in the S, 6 in the P, 10 in the D, 14 electrons in the F. And if we divide by that by 2, we'll get the number of orbitals. So this will be 1 orbital, 3 orbitals, 5 orbitals, and 7 orbitals. Remember, an orbital can hold 2 electrons. Okay. Oh, there we go. Max number of electrons. Actually, this is orbitals here. 1, 3, 5, and 7. When writing electron configurations for any elements other than hydrogen or helium, you must always start with the 1s and work your way up to the atomic number, or the number of electrons that the atom has. Okay, so hydrogen, 1s electron, 1s1. The first electron on hydrogen goes in the lowest possible energy level, the 1s, so that's 1s1. Helium has 2 electrons, and so its configuration is 1s2. The 2 electrons for helium will go in the lowest possible energy level, which we call the 1s. Since the 1s can hold 2 electrons, it's now full. So we can put 2 in that s level, and it's full. Now lithium has 3 electrons. Lithium will require the 1s shell and the 2s shell. The first 2 electrons will go on the 1s, and so that's why we get 1s2. But then it's full. The third shell must go in the 2s, so that's why it's 2s1. So the first 2 electrons can go on the 1s, and then that third and final electron will go on the 2s. And then it's out of electrons because it's only got 3. Okay, this is our complete electron configuration. This is the order, so if you get lost on the order. This is the complete periodic table written in terms of electron configuration. So hydrogen is 1s1, helium is 1s2, and this is just showing the valence electron. So if you write the configuration for the last element, so like let's do this one, which is lithium. So it says 2s1 there, right? But we got to understand that lithium is 1s2, 2s1. Okay, and so this chart is only showing the last level. It's not showing anything beneath it. Like here, here's boron. Boron's configuration is 1s2, 2s2, 2p1. So notice that it says 2p1 here, and it's only showing that valence shell. Okay, it's 2 because it's on the second level. There's the first level, there's the second, and remember this is the p block. So that's why it's 2p1. Okay, that's it, guys. I hope this is helpful. Have a good one.